I just got an offer with the Intel, and then in the Intel almost 5.5 years I worked as an BIOS engineer. I'll get into the details of what does the role of BIOS engineer would be in generally would be. And then from there I moved to another company called Juniper Network, which is into network and cloud computing manufacturer and then service provider in general for various big companies. After that, I just joined Microsoft. It's been more than a year now. So here in Microsoft, I work as a senior software engineer. We all as a team support for the cloud infrastructure. Let's say that you are using Microsoft Teams or Microsoft any other services. So they are all delivered from the cloud called Azure infrastructure. So I'm part of the team to support whatever the firmware and some of the services related into embedded world basically. So this is about myself, and so this is all what I have been doing. And then I'm fortunate that I've done my engineering in the electronics, and then got an opportunity to work into the same core domain of electronics and then communication. So from there on, I have been enjoying this entire career by learning the new skills and growing. And then today, working for companies like Intel and Microsoft definitely is a big thing to my overall journey, where I have learned and then grown to current position. Okay, this is about myself, and then let me move on to the embedded systems. I think you might have a basic understanding of what embedded systems are, or what do we can do with the embedded systems, or what are the kind of applications in the market. But let me reiterate that what do we mean by embedded system. Basically, uh, we know that computing devices, not just computers, it's a computing devices. Any electronic device which has the ability to perform logical and arithmetic and read write operations based on the instructions format is nothing but a computing device. For that reason, the first device or first electronic device which we would say which does this activity is nothing but a processor. Computer is a lot of peripheral connected device. The key part is the processor, right? So here I'm talking mainly about the processor. So it does a lot of activities like if you ask to do basic math operations, it will do, and logical operations like if else, or like do this versus that or something like that. Those and all can be constructed through the programming languages. And read write operations in the sense like some data you wanted to store it in the memory and then read it back or something like that, and make an updates to that. All pretty much will be managed by those devices, are nothing but computing devices. And the second thing after the computing devices, we have a computing devices. The next thing is the
Vishnu, sorry to break through. Are you moving the slides? It will be helpful, I guess.
yeah, I'm presenting what is embedded system slide.
Okay, no, is everything, everyone able to see the slides, or
No, sir.
Who
Same
am in
slide.
slide is visible, sir.
because we are stuck at whom am I slide?
Let me reflash that
Yeah,
now.
now I can see that you have moved to
Okay,
what
sorry
is
for that.
embedded system.
Yeah,
Yeah,
yeah. So first
thank
thing
you.
is
You
the
can continue. Sorry.
computing devices, and the followed by that is the firmware. So we would have heard here and there firmware or something such terminology. What is the difference between a software and firmware or something like that? I would wanted to first touch a differentiation, as well as like what do you when you call something as a firmware or something like that. So if you look at your laptop or any mobile devices or something like that, it's a completely layered kind of stack, where there is something which does not need to aware about that what is the underlying hardware, and so which acts as a something in one layer of that, which is pretty much majority of time we call it as an software. Let's say that any such coding which is built on as a like in a stack, which does not necessarily to understand how does the hardware work underlying. So that's something most likely we call it as in a software, right? So then when we are building a lot of such things, right? So sorry, what? So when we are building a lot of end products which pretty much dependent on the hardware devices and hardware kind of stuff as an integral part of the designs. So so if any coding which talks or which deals with the hardware is nothing but a firmware. Let's say that if I wanted to get something done using the hardware, so you need to provide some way to those devices how they will actually take as an instructions and able to work as per that. So the code which we write it to make to the directly to the hardware devices is nothing but a firmware. So going on to the next step. So now we know that from computing devices, now we know that firmware. So now if you make end application putting together this computing device and building or writing a code which is going to control that device to get end functionality is nothing but an embedded system. So embedded systems in generally have a confined functionality. Let's say I would say that some of the examples I will run through, and then you get that understanding why certain things we call it as an embedded systems when we are designing or when we are implementing something such end applications. So you'll get an idea. So let me walk through some of examples, right? So here a smartwatch or wristband is one of the wearable embedded solutions. So today you would be having variety of wristband you might be using. So primary functionalities are like tracking your footprints, tracking your body pulses, or many other stuff which is part of your body to uh, collect as an data to help you give you the right suggestions or something, right? So here the functionality of device is very limited. What it can do is it can sense your pulse. What it can do is it can identify your movements, and what it can do is anything like body temperature or minor other stuff, right? So whatever has been defined, it is a very much defined, which is defined in the sense like say that you could only get that functionality done using this device. So pretty much whenever we talk about embedded solutions, they are with a one particular purpose and then one particular functionality. One particular functionality, not necessarily like, you know, okay, we are measuring the footprints, is that mean only one functionality we are going to take care? It's not like that. It is in the exactly the scope of that functionality is limited or being confined, right? So that's what a majority of embedded applications are done in an implementation way, right? So can I call the laptop as an embedded solution? Partially it is, but it's not 100%. The reason is the laptop has been built in a way that multiple software layers are firmware under the software. So all the hardware what it is connected with has a limitation. So what on top of the software will run is also have a little bit limitations, but it has the ability to run more generalized applications which do not depend on the hardware. Let's say that you wanted to run a game. So if you already have a display and if you already have a keyboard and if you already have a mouse, it's pretty much enough on the laptop to run a game, right? So if you wanted to take like some measurements, or if you wanted to take like something like can I take my room temperature from the laptop? May not be. The reason is you have to attach some additional hardware to that. That hardware comes with its exact functionality, what it can help you to get the data, right? So in general, that is how the embedded solutions are going to be. And when you look at the laptops are pretty much like in servers or whatever it is, the bottom, when you keep looking towards the hardware implementation, they are pretty much like an embedded solutions. But the top side, you look at it as an like multi-threading, running any software or something, like it's not limited to the functionality. It is something like a software as a solution, something like that. So that way, laptops and computers, many other devices works as an in between. Like but it's very hard to differentiate that whether it's a completely embedded system versus not an embedded system. It depends upon the use case and application. So smart bands and one of the applications in that which is going to clearly say that it is an embedded application, we can call it. The next thing is, so these are the few.
Vishnu, before I think you may present that PPT. I can see the slides, but it's not moving. You are in third or fourth slide now, right?
Yeah, so I don't know, like when every time I'm moving slide, it is changing for some reason.
Now we can see fourth slide.
Okay, so this is the electrical chargers, which are pretty much available in US and kind of country Western countries. So today, how it works and what are the functionalities implemented is pretty much limited. but it is has been implemented in a way that it can take all that step-by-step approach to execute certain things. Let's say you pick up the gun and then it knows that somebody has picked up the gun, and then it will enable the screen to you to interact with, and then you can enter the fuel amount or something like that, and you can make a payment. From there it is going to unlock that fuel moving pumps, that pipes and all, something like that. But if you look at the application, it is confined and it has a microprocessor, and there is a code which is running, which is nothing but firmware, and there is some storage which is going to hold the database, something like, let's say that when a customer transact, let's say that 1,000 rupees fuel has to be pumped up, or like in the charging has to be done or something like that, right? So you make a transaction, the data might not immediately move to the cloud immediately, so it might take some time. Sometimes the network connectivity might be weak or something like that, so it'll have to store some of your data until it is being completely pushed onto the cloud. So along with that, you're running firmware, or you're running the code, whatever it is, also required some sort of memory. So all put together, there is a storage, there is a processing unit, there is Wi-Fi or internet connectivity to push the data into the cloud, so that you have a track record, who was the customer who paid, and how much fuel he has been like how much the charging he has been consumed for his vehicle or something like that. And also you have a lot of these end devices like touchpad, like when you are tapping the numbers and then the screen is changing, and then you are making a payment. All that is part of embedded solution. And then Rajesh, is that the next slide is changed, or
No, it is still in 4.
yeah, let me
And
now.
now I can see ATMs. Yeah,
Yeah, so
I need
the
inside that. We
yeah,
need inside that.
yeah. So it's basically ATMs are also a standalone embedded systems connected with the connectivity, and then also have a ability to take or interact with the people to process the transactions through the connectivity. It just moves some data in between your ATM machines to servers to get an acknowledgement that you have a money in their accounts or not. It is just like something, they call it a ledger, and then it just get a confirmation. From there below they have some money dispensing mission. So once it gets an acknowledgement, it start dispensing the currency to you. So all, if you look at it, it's a bits and pieces of tiny hardware built for a purpose of dispensing the cash. So these are other example, like your payment machines, or yeah. So I'm not sure that you're part of Bangalore, but if you look at BMTC buses and all, they have started bringing payment machines also into some buses, and then it's become more usable to the people. Like you would have had thousands of transactions done so far in the many retail stores and all. So here it's also one of the embedded solution. It has a very limited purpose, and it has a very limited functionality. It's like wanted to do the transaction of collecting the money, and then using some physical interactions with the device, like entering the amount, and then swiping the card, and then talking to the ledger server, so that it can get the confirmation as if like your money is moving from your account to the merchant account. So again, it has a computing power, it has a storage, it has a connectivity to the internet, and then user interface is nothing but a touch screen.
Yeah.
Yeah. Yeah, so these are the four examples I would wanted to touch upon, and then so that you get a basic understanding of what an embedded system is, and then let's say that what would it require as a skill, right? So basically, when you are writing a Windows application, you wouldn't require to know anything about what is the logic gates, what is the storage mechanism, what sensor is being attached to the device, what is the network card and all. But if you wanted to pursue a career in the embedded system, definitely there are certain knowledge you have to have it as a like part of your academics you learn, but these are the fundamental skills which are used in daily life of like an embedded engineers or BIOS engineers or something like that. So it starts with the logic gates like and or XOR applications. Though you wanted to do arithmetic, logical, or more other activities, whatever using these computing devices. So all this is being provided in terms of instructions. So these are some of the logical implementations underneath the CPU or any computing device. And storage, like say that you wanted to write some data. Let's say you have some number which you wanted to perform a math operations. So either when you are doing that math operations and again storing that value for later usage, you have to put that into some storage, which is typically in electronic words you represent it as a registers. So a hard disk or USB thumb drive or eMMC card is nothing but a storage with the registers or like small bits being able to store the data and then able to retrieve when they want it. The next thing is like sensors. There is a lot of different types of sensors available in the market. Like ADC is nothing but analog to digital converter. Best examples for ADC is your temperature. Temperature is in general analog, and then that need to be converted into digital. So that let's say when you say that 23 degrees temperature, right? So and then you wanted to turn on your AC based on when the temperature goes beyond 30 degrees, right? So there is a ADC device which is going to sense outside temperature and gives you a digital value, and then your program can make a choice of that. Do I need to turn on AC or not? So if you have seen home automation, it's pretty much like based on a lot of sensors. So when you turn on your fans, like pressing a button is also part of the sensor system. So whether it is connected with the programming or like automation or not, it's an extension to that. So if you are using a thermometer just like that, it does not require a firmware or any software to give you the data. It is just like very simple implementation of electronics, like analog to digital converter, which comes without programming requirement. It is a device directly give you a digital value, and then that digital value is what you see it on the thermometer or temperature guns, which you would have done it in the COVID times, right? So but if you have to extend that intelligence, like say I have a temperature, how do I use this for decision making or doing something beyond, like I would say that just knowing the temperature, let's say turning on AC, turning off my geyser. If I wanted to do a lot of automation, all this sensor data is being taken from the digital format, and you have your program which is going to make logical decisions based on that and control the other devices what you would like to. Let's say you sense a temperature. AC is a completely different device, right? So you have a sensor which is going to sense, and there is a computing device which is going to take the data and then make a logical conclusion that do I need to turn on the AC or not. And then there is something else, a relays, they call it a switches, which is going to turn on turn off based on the I would say that logical values like bit 0, bit 1, something like that. So your computing device can control your AC power using this relays. So now if you look at this is a just small simple home automation which is based out of your sensors and based out of your computing device as well as your end application, the end the device, something like AC, right? And inside AC also there will be circuitry. Inside your washing machine also there is a lot of embedded solutions, and inside microwave oven, inside your TV, inside your now latest whatever the locking system, so many applications are there. But if you have to contribute to the solution, you should know a lot of these things. When you're really being as an embedded developer, you can contribute to the solution means. So networks, let's say that and something more fundamental concepts which you have to understand. Say that how does my data transmits from one tower to the other tower, and when I send a data over the broadband connection, how would it move or something like that. So these are all some of the applications of this embedded things. And these are the some of the fundamental concepts which you would be required to know that when you wanted to make a designs or implementations on top of this. And the next thing is going to be like programmings. Basically embedded solutions are highly dominated or highly in use based out of the C++ programming. And then there is something data structures and algorithms uses when your application is very intelligent or something like that. But for basic programming and all, you would not require too much of algorithms, but you use the data structures. This is what highly like what it would be and a skill set what you would require to know for basically to actually do the embedded job. I'm a BIOS engineer. BIOS engineer means like basic input output you would have heard from your academics or something like that. So basically, when you are making a laptop, or when you are making a building and computing solutions like servers or something like that, so there are a lot of devices connected to it, and OS directly cannot do a lot of such things. So in that way, they have broken entire solutions in a way that first comes a firmware which is going to establish all the interfaces like storages, networks, and a lot of initialization happens. Once everything is set up, then it will just give the control to the OS, and then from there OS will run, and then firmware part will actually 80% of firmware stuff will exit from the memory, and then very few dynamic or runtime services will be available. Most of other services will move out of the memory, and then you wouldn't see that firmware coming back unless you reboot the system. So I'm part of the BIOS development, which is what we do it for Intel, and now in the Microsoft also I do part of that same no, like teams contribute to this interfaces and initializations, which my just one moment. So which is going to be consumed by this OS and OS as an application, OS as a consumer. When it has to run its OS, what does it require? It requires a hardware which is already fully initialized and ready to copy your OS into that, and then from there it can run, right? And then you would require keyboard to be ready, and you require you use mouse to be ready. You require a lot of networking Wi-Fi interfaces to be ready. So the code which is going to set up all this stuff, and then keep everything ready, and then loads OS into a memory, is the BIOS, which is going to do that for the OS. Once it does that job, it just transition, and then it gives a full control to the OS, and then from there it exits from the memory. And then again you reboot. First again BIOS will come, and then we'll do all this job, and then we'll launch the OS and give the complete dump of the system resources after initialization to the OS, and then it exits from the memory. This is about the BIOS. So I'm part of Intel team where we were doing laptop designs, in the sense we do something called CRBs, customer reference boards. Who are our customers? HP, Lenovo, Dell, Asus, all these are our customers. As Intel do not produce the end laptops, we only make the processors, and then we prove entire solution to be fully functional. In order to prove that the functionality of entire system, which is based out of a process, which is using the processor and other peripherals, we have to give the sample code. So we do develop that code, and we do validate end-to-end functionality within the Intel when we were like first time bringing up the new processors and covering the full functionality of the device. And then we ship the processor, and we also share the code to them. This is what our code, which is proven to be fully functional, and you can make changes to that code, and you can also design your systems slightly different from that what a customer reference board which Intel does, and then give it to the our customers like HP, Lenovo, all this stuff. From there I moved on to Juniper, where I was also part of the Juniper similar team. There they build a network servers which is going to host the OS, which is like what Linux. So in order to launch the Linux, the system has to be fully initialized, and from there it will hand over the control to the OS after loading the OS onto the memory. From there the Linux will run. On top of the Linux, there is going to be some network applications running to help that network activity to happen. So that is what Juniper networks into network, like moving the packets of the data of what you do in the your Wi-Fi and majority of other communication channels. They act as a channel to exchange the data between one point to other point, and that's what they built as solutions. In these solutions, so first BIOS comes and it loads the Linux OS, and then Linux OS launches the application something specific to network activities. That is how it works. So I'm part of the BIOS again in the Juniper network. So now I'm part of the Microsoft, where again I'm part of the Azure network in hardware and infrastructure. What do Azure does is, so Azure is again like a services which is running on top of the Microsoft. We do program firmware development as a BIOS. So whatever we get it from either from Intel or AMD is another processor manufacturer. So we get a processor from one of this, and also get some code like what I was doing as part of the Intel as an end product and its services to the clients. So Microsoft gets a processor along with that code, and then we take it and we customize it as per the Azure requirement. Azure requirement in the sense like it's like typically like what, why, and what they wanted to achieve using the Azure hardware. So they will have a set of requirements. So we work to customize this firmware to get that functionality, and then clearly having full functional coverage from the Microsoft. On top of that, Azure applications being running on the cloud. So this is about my job role in the Microsoft. And most likely you don't know that what and all typical companies who will be having the embedded jobs or something like that. So let me show you companies which you are very much familiar, but you might not have a full picture of that. So Rajesh, can you just confirm me that you could see that the logos of companies which I have put it? This is just 20 to 30% of the
Yes,
logo.
I'm able to see that, and
Yeah,
I hope everyone can see that. Yeah.
yeah. So this is just some big companies which are of only 20 to 30% of the companies which I have put it. There are so many companies which deals with a lot of embedded products and then embedded jobs. So title may not be exactly embedded engineer, but it is a software engineer. And then you have to eventually, like in Microsoft, my role or title is not a BIOS engineer or firmware engineer. It is a software engineer, senior software engineer. So the role might be same, but you have a background of electronics and you have been working, or you wanted to work in electronics and this kind of embedded world. So roles might, the title might be differ, depends upon the companies to company. But the thing is, pretty much a lot of these companies do very good and big works in terms of embedded works, like Apple does your smart bands and so many of gadgets which are Apple does. At the same time, Intel fundamentally builds so many end applications to demonstrate to its clients. Basically, like if you say Juniper, right? So Juniper consumes Intel processors. Juniper consumes AMD processor. Juniper consumes ARM processor. ARM is another company. It's three companies are there which are currently in the market, produces the processor and controllers. So they are like one Intel and then AMD and ARM. So as Juniper Networks also builds a lot of embedded solutions for network and cloud and storage purpose. So all are going to use processors built by either any one of this Intel or AMD or ARM, right? So when it's like this is a one set of customers for Intel. There are the different set of customers which are like going to be doing IoTG solutions. Let's say Apple builds solutions like footprints, like or like your temperature count and all. It has to go into the cloud, right? So it's a solution, something called IoTG. IoTG is enabled solutions. They take the data and then pump it into the cloud and build your Android applications, which collects again from the cloud. This is a entire circle of that what IoTG implementation, right? When Intel wanted to sell a small or low capable computing power applications, Intel does demo or like what do you say that products for demoing to the clients that using a processor. These are the type of products you can do it. These are already available in the market. So if you see that lifts, right, Johnson and Johnson and something like that, even they use the Intel processors. And then if you go into the Google, so Google like a lot of embedded applications, they continue to do it. They will do it. Qualcomm's, Broadcom, as well as some of these things are directly or indirectly uses a lot of processors from the Intel, AMD, or ARM, and then build a lot of applications for network and security and cloud related. So LG, like LG would have heard that from your childhood, right? LG has so many applications which are pretty much into embedded systems, like your washing machines, your dishwashers, and your microwaves, and you have a TVs. All of them have a big role in terms of embedded solutions as part of their end products, right? So they have a big teams who works on the firmware development and then device development, a lot of such things, right? Nvidia has a graphics card which also requires some sort of firmware. So both, now you would have seen that a lot of your headsets and a lot of things coming, right? So they're also like getting into a lot of small electronic devices which uses the software and firmware. And Atmel is this one of the chip maker, like your storage chips, they will make it actually, like whatever the program we write. And then Samsung is the biggest other vendor. which does a lot of embedded solution. Your mobile phone is nothing but when you go onto the hardware level, there are 100 plus embedded applications which are part of your end solution. So though on top of that, an Android runs. Android is like little bit, I would say that hardware abstraction through this embedded or the firmware layer. Like in the software running on that. So these are very few list of the big companies which you, by looking at this itself, you can understand these are the companies you already familiar with. There are hundreds of companies which are working on embedded solutions, and then like there are so many opportunities, but you may not exactly see it as an embedded as in a role. You might sometimes see it as a software engineer, but if you go on to the details, like they would say that do you have a familiarity with the CPU architecture, or electronics background, or familiarity with a lot of sensors, network interfaces, something like that, right? So that's how you'll be able to understand these roles are ideally an embedded roles but titled with slightly different. So this about like a high level overview of that what it is, and then how what is the market, or what is the like companies which are going to have some roles for you in case if in future you wanted to pursue this as a career opportunity. So from here I just leave it to you for Q&A and then open discussion.
Great. That's a wonderful insight about your career and a few of the examples you have showed and few of the companies where it's really embedded matter. And I hope it will be helped a lot. And before I open up to the students for their questions and their feedbacks or where for their career tips and all other things, I have one question where I need to start with Vishnu. And today that so how this artificial intelligence and machine learning is playing around in the market. So what role do you see this artificial intelligence and machine learning playing in the development of embedded systems, and how do you approach incorporating these technologies into the real-time work?
Yeah, so when we say that artificial intelligence or machine learnings, in generally it works pretty much on the high level of data, right? So embedded systems are, if you look at like in US, there are many trials happening for autonomous cars, right? So they all going to share that when they're passing by the vehicles, they reflect the data, and then all the data goes back to the systems, right? The majority of end devices which is going to collect this information is nothing but embedded solutions. So these are very tiny solutions. Let's say it senses the temperature, it senses that the weather condition when you're driving a car, and then it sends to the cloud where it is going to provide a suggestions to the other people through mobile device or any other interfaces, right? And today, like if you look at like in a lot of after post COVID, a lot of people are keeping the wristbands to check their temperature. So all these are pretty much like interlinked with the machine learning and artificial intelligence, because like once you started seeing that 100 people collapsing because of that temperature change or something like that, the device which is capturing the data is embedded solution, and then the leverage of artificial intelligence and machine learning can provide a suggestion saying that these are the patterns which is being recognized for the people who have been infected or affected. So you use this data to make a change of your plan, or whatever it takes you to just protect it from that situation or something like that, right? So let's say that even road damages, right? Somebody just enter some places and like stop by there, after seeing that there is a data collected from that one vehicle and then goes into the system, right? That's also in some of the embedded system solutions. Now it is going to be in a by default integral part of this high level artificial intelligence and machine learning solutions. Basically, artificial intelligence and machine learning is nothing but a heavy and high-end software which runs by on top of the data. So who is going to provide you the data is nothing but your embedded handhold solutions, right? So it is inseparable. If you ask me that the going forward, like next 4 to 5 years or 10 years, the solutions is going to be very big, impactful. The reason is so far, like say that 3 years before, you have a temperature gun to check the temperature, which is not getting into the cloud. So that's not usable by machine learning or artificial intelligence. But the solutions today are like your rest brand, or like many of such solutions are pretty much tightly connected with your clouds and artificial intelligence and machine learning. Now, without these end devices, you could not collect those data. So which means that you obviously have to have these devices. And now the importance of these devices is slowly increasing, right? So you would now see that wristband consumption has been drastically increased. The reason is you wanted that what is your pulse rate, what you wanted to know, how much steps you have moved in, and you wanted to know a lot of other things like what is my pulse rate, all that stuff, right? So without a wristband, would you be able to take any data? So it's pretty much like visiting the hospital and checking using those old type of devices, right? So pretty much the control is, and a lot of data is flowing back to the consumer, but the first device which is extracting the device is embedded, and then now it's being plugged into the end solutions like artificial intelligence and machine learning.
Oh, great. Like I would like to students to raise their hands, like, so that they can trigger their questions and, get some insights as it's open for questions, guys. Okay, we have Kirtana. Uh, yes, Kirtana, you can unmute and you can ask the question.
Hi, sir. I'm Kirtana Sharma. I'm studying third year BTech, sir. Thank you for your presentation. Can I know which domain will help, sir, when compared to VLSI and embedded systems?
So basically the thing is, yeah, so for me also, when I just stepped out of the college, it was not evident that I wanted to pick VLSI or embedded systems, right? So it's an opportunity. So basically, it's equally exciting as both the careers. Like, so I most likely Rajesh is also scheduling some other guest speaker who's going to talk about the VLSI.
For the
So
VLSA, yeah, we have planned that.
we both are classmates, and we studied in the same college. And then he works for the best top company which is in the world for a silicon manufacturer. He's into VLSI. I'm part of the best companies what I have been to my career. So there is no regret that whether I have picked up embedded versus I did not pick up the VLSI. Neither he has, right? So the thing is, everything is exciting. Everything is, every phase of that is a new learning curve for us, and we constantly uh, like, it's like if you're part of the Intel, it is always constantly it's making itself as a technology innovation leader, right? It's not that somebody is going to tell that Intel you do this thing, or AMD to make this kind of chips, or Microsoft to work on the like chat GPT, right? So now you would have seen that. Did anybody told Microsoft to work with the open AI to be part of the chat GPT? No, right? It's all they themselves put for innovation. And Intel does so much of VLSI, Intel does so much of embedded implementation. So if you knock with any opportunity, it's anything, everything is best. I would not say that like I'm being in a part of the bias or like an embedded developer, how it would look like, because I would have given with the VLSI, so I would have been enjoyed the role, because I love being part of this journey as in learning and then growing. So it could have been anything is best to me. So for you, it would have been a confusing that like I don't have much clarity. See, some of the things are opportunity based. Some of them are interest based. Do you still wanted to learn advanced coding or something like that? Embedded has an advanced coding features, which like say that I'm part of the Microsoft now. Let's say I wanted to switch into typical software implementations of Microsoft. Since I'm having the coding familiarity and programming fundamentals, I might be able to switch my career into something non-embedded also if I wish to, right? So that is a one small advantage I would say it. But if you love what you have interest towards your electronics, I would say that both would be very fantastic to choose.
Thank you, sir.
Yeah.
Good. So I think the other person has raised the hand. Varsha, I guess.
Yeah, sir. Good morning,
Yes,
sir.
please. Good afternoon.
Good afternoon, sir.
Please go ahead.
Hello, Vishnu sir. Good afternoon. myself, Vishnu.
Yeah, hi Vishnu.
Sir, may I know that uh, the, these are all core companies, no, sir?
Can you repeat again?
These are all core companies, no, sir? Which you work
Correct,
for
correct.
hardware. Sir, what I understand is core companies means we have to deal with hardware, we have to work on that, we have to do like machines, we have to repair that like that, no, sir? Apart
Yes.
from that, anything can we do in that core companies, sir?
See, Intel or Microsoft or AMD does not mean 100% of their work is something related to core. So they also have a lot of infrastructure related stuff. Like say that we wanted to build an IoT applications, right? So we do design embedded solution, but we are not much familiar with the cloud solutions, which is AWS or something else, right? So there are going to be engineers who is going to support that. And then any other stuff like you would have seen that Microsoft is not fundamentally high in terms of embedded, but they are more in terms of software, right? So I'm being an embedded or like an electronics background, I got an opportunity to be part of the Microsoft biggest team, right? So for the core product which is delivered to the end user is service as a software as a service, which is Azure or whatever it is, right? But I'm contributing to the hardware infrastructure of the same, like say that for end solution of the service which they wanted to deliver. So in Microsoft, 80% or 70% of their roles or development is related to software as a service like SaaS or cloud computing, but 20-25% is something related to hardware and electronics and embedded related. So it's a mix basically. So you definitely will have a lot of other opportunities also with these core companies. Apart from that, core related work like embedded VLSI something, apart from that there are more other opportunities also with the same companies.
Yeah, sir. Then one more question, sir.
Yeah, please.
Sir, in core companies, all 100% it does not depend upon the hardware. Software also is dependent, no, sir.
Correct.
How many we need some knowledge about software, like about some programming language. We have to know. Yeah, apart from that, anything we have to know, sir.
Can you no, I didn't get the question correctly.
Sir, in this core companies, we will be doing hardware job, no, sir. Hardware things.
It's not hardware job, don't call it a hardware job. So you see, the thing is like, you wanted robot to work, it looks exciting, but when you see that a robot is sweeping your home, the things which required is lot more than just a hardware. It looked like in a hardware, like the legs and hands and head being look like in a physical some aluminum stuff or something like that. Underlying there are some lot of intelligence which is from the hardware as well as also firmware and software will also be there. And then when you are doing a lot of this application, not necessarily like it need to be very much tied to the hardware knowledge or something like that. You can build an applications which is going to be like you like today the smartwatches are having a call taking provision, right? So you have a smartwatches you can tap on and directly take a call. What is there to have an embedded application into that or something, a small mic, and then that mic delivering your voice or microphone or mic or something like that. Apart from that, in order to implement that end application on the this wristband, you don't need to understand hardware. There are the APIs which is provided by your Android system. So you just use that APIs to push the data and then play with that. You don't need to know about a lot of such things. But the underlying hardware has been already taken care by in a stack which is Android, right? Android will
Okay,
give
sir.
mic
Yeah.
or microphone or something like that, and it has a network module and all it will take care of that. You only have to call the interfaces to build your application, and then you have to integrate the touchscreen functionality. Like you tap on the touchscreen when call comes in, you will be able to answer the call. So you don't require it's not that you have to know that 100% of knowledge to make an end applications based on the embedded solutions, right? It's like a lot of your mobile phone, right? You play a lot of games, you have a sounds, you have a graphics and all that. You wouldn't even understand that pixels and something. A lot of times you will be able to build a like in a graphical game. It is running on the embedded solution, because the graphics that the display has to work. The display driver is nothing but interacting with the hardware, constructing the pixel to represent an image, but you don't have to. You use the APIs or interfaces, whatever it is there, you can directly build a solution. So it's like, so you could be building pretty much solutions based on top of the embedded hardware, and then stack which is built, but you don't necessarily need to understand. That's what, like, you are using a laptop, you wouldn't even understand how the keyboard works. You write a program, you don't even understand how the keyboard works. Like a lot of, like, your IT and software, like the entire jobs, if you look at how mouse works, how keyboard works, it does not matter to you. You are just being consumer of that, and there is a Microsoft providing a solutions to you to access those APIs and build your application. So it's not strictly like, if to answer your questions, you don't need to have 100% or any knowledge of embedded to build solutions which is going to run on top of the embedded products.
Good. We have Pujita, you can ask now. You have raised the hand.
Yes, sir. Good afternoon, sir.
Good.
Sir, actually, this embedded systems is like completely for EC, or CSE students can also approach to it.
See, it's a very question, something today, people who have not done the fundamentally IT education, they're into IT. And people who are doing computer science not necessarily need to hold themselves for only for IT. See, what I would say is, if something is exciting you, that like I wanted to pursue this, feels me like, the thing is, anything you study also, if you don't have interest, you wouldn't be able to anything useful for that. If you believe that this is something interesting to you, put a lot of efforts understanding that what does it takes to get there. And if that interest is continuing for you, then you can pursue. It does not matter today. I don't think now the world has completely changing. Next 2 years, 3 years line, it's going to be completely different. You wouldn't need to worry about that, what is your academic curriculum versus what job you are going to do. Does not matter. It's completely different, and you can keep it as a career option. But the thing is, you have to explore more. Like, just jump onto the, like, Google, search in the YouTube, understand first what does it, right? A lot of people have geeks have made YouTube videos to write embedded programs, and how does it work. And there are like small kits to do self implementations of embedded solutions or something like that. It costs you 5,000, 3,000, something like that. You could explore the interest first. If you still believe that this is still exciting to me, I'm saying you that, like, there's nothing you need to stop yourself for pursuing this.
Okay, sir. Thank you.
Yeah, I think we have one more question from Kirtana. Yes, Kirtana, please proceed.
Hello, sir. Sir, can you tell which type of skills make your career in Microsoft, sir?
See, the thing is, though I'm a embedded developer, so I have to clear first the programming skill. So programming the skills in the sense, data structures and advanced algorithms, that is the fundamental to enter into Microsoft. Even for Google, for Intel, if you say Intel ask for domain specific knowledge, which depends upon the what role you are going into. But companies like Microsoft, Google, and Facebook, Netflix, and something like you would have seen in the YouTube, that's a craze typically there. That is even practically also true, that if you have to, so the thing is, if you start working on various platforms like Lead Code, Hacker Ranker, or something like, those are the platforms you need to practice for programming. But you need to gain the advanced knowledge in the programming. That is fundamental for embedded, that is fundamental for IT and dependent jobs everywhere. But you have to be good at programming. That's by default skill, because like the thing is, now so many opportunities coming to India in terms of like be it an electronics or IT and all, everything pretty much 80 to 90% people required programming. It's nowhere, it's not like in olden days, like you are going to be a hardware engineer. So even I have seen in Intel and many places that people have a dual knowledge, that who has a complete understanding of hardware as well as the programming knowledge, which means that there is no more criteria that, like, okay, if you are going to be a hardware engineer, you would be sufficient to have only hardware knowledge. So even if you wanted to pursue embedded or something like that, or only hardware roles or something like that, you pretty much need to exhibit that good programming knowledge. So you have to start programming and advanced programming in the data structures and algorithms. There are plenty of materials in the YouTube, and then there are like in a competitive portals where like lead code and something like that, where you can test your skills and then focus more on those learnings, and then how do you improve your programming. So those are critical skills for like in a top companies basically.
Great.
Thank you, sir.
I think one more question from Varsha.
Sure.
Yes.
Sir, can you say about the internship opportunities and what kind of internship did you do, sir?
So basically, Microsoft or Intel, I've been part of these companies where I've been also to some colleges, but they have a list of some reputed colleges. Basically, that's where they actually send us to select some candidates for 6 months, 9 months, 1 year internships. So that's where they will be given with some like in a small tasks to or, work on and then come back. Let's say that we wanted to do some optimization, we wanted to do improve some power metrics, we wanted to do like some keyboard functionality efficiency or something like that. We would actually hire somebody as an intern, and then those people will be put into a company, and then we give those tasks to them, and then they will actually started showing up some interest to work on, then seek our guidance to get the job done. So that's how people come for Intel and Microsoft from NITs and IITs in generally. So that typically Microsoft or Intel has a lot of tie-ups with the reputed colleges basically.
Thank you, sir.
Thank you.
So we are open for question, guys. Like anyone, any questions? Anvesh, I think you can ask. You have typed, I guess. So can we make use of embedded system involved in space technology?
Yeah, space technology is huge, right? So you have I would say that so pretty much like temperature, weather, a lot of oxygen level sensors, and then so many things are by default a part of your satellites. That's where, like, when you send somebody as an astronaut to the all that, right? It's more than like so obviously nobody can hold the guns and check all that stuff like what they wanted. So they will have 100 200 parameters which need to be always monitored as in a protection to your system and people who are in the space, all that stuff, right? They all will be having so many such sensor and parameters which are constantly communicated back to. So it's like your satellite network is also part of the bits and pieces of embedded system. So you have some modem which is going to radiate that signal from one tower to other tower, one satellite to other satellites, and that's being grabbed and put into system for interpretation. Like you would have seen I think Virgin, and then like Tesla and all, they have done this like recent launches of that, right? So you could see that all the video coverage, everything video coverage is also like so the thing is, satellites and Wi-Fi network is fundamental part of the electronics and solutions. On top of that, what applications you are building, whether you are sending a text, whether you are sending a video data, whether you are sending something else, is an end application, right? When you saw that Virgin or like a Tesla videos, they have made it during when they went into sky or like a space, right? So all that video broadcast is because of that your electronics, and then the computing, and then your communication, everything is fundamental blocks of your electronics and embedded solutions. So it's a huge, like it's a huge subject in general. So there will be plenty of use cases where in the space embedded is used already. It's not something that we wish to use or something like that. There's thousands of use cases which are already being used or something like that.
That's great. Yes, Sambasivarao, you have another question.
Good afternoon, sir. I'm Sam Surao. I'm
Yeah.
from UCE department.
Yeah. Hi, Sam.
I'm a third year student. Like, what are the skills that we require to get into embedded system as a third, like after completing BTech? Like we are
So
having microprocessor, microcontroller. Do that skills are required, or else we require any furthermore skills to get into embedded system jobs?
Hello, Vishnu. Am I audible? Hello.
Sorry, sir, you are audible to me, sir.
Okay.
sorry, there was a network breakage.
Yeah.
Yeah, let me answer it again. So you already have a lot of academic subjects like logic gates to VLSI, and then you have embedded programming and C programming and all. So what you might be missing is you need to do some practical programming, something like that. So sometimes what you can do is, like, there will be some programs which are already pasted in the web for embedded applications. You just go through that and then also improve your programming skills and fundamentals of logic gates, and then all your electronics stuff you have studied, and you have to explore more. Now the thing is, apart from the academics, you have a lot of content which is there in the YouTube and then Google, which you have to improve your skills level. Because, like, I've also studied, and I have also something which I have a limited understanding when I was studying, right? So now each and every day when we have something which we are not familiar, first we definitely will, every single organization will have a people who are going to help you out, but we still don't want to be more dependent, asking all the questions to them. What we do is we go to the Google and YouTube or wherever it is, like, a lot of information we try to search and figure it out, understand. Like, let's say, like flip flops, right, in the embedded world, like in the one of your subjects of electronics, right? We have studied long back. It's
Yes.
13-14 years, right? So now we, if in order to understand, recall that back, I go to Google or YouTube to restudy that, and there are videos and best understanding material. That now, if I look at that, I feel that, like, oh man, there's a lot of good information already there in the web. I did not know when I was studying. I did not have this access also. Now it is pretty much, you have a lot of information already in the web. So what you have to do is you have to self guide, you have to make yourself towards what is interesting to you, and then put a lot of efforts to do deep dive into that. So in academics you don't deep dive. You have been taught to certain way, and then you feel that that is maximum information or something like that. But you have plenty of information which gives you lot of details which you would feel that, like, okay, this is not covered in my academics. And having understanding of these things, feel more confident. And then, see, the thing is, the more the information you gain, the more confidence you gain, right? The more confidence you gain, every single interviewer, even while trying to hire a fresher, they would look for your confidence and then familiarity of the subject, not actually being more experienced versus how good you are at all the stuff, right? So they would look for your attitude and your confidence. The confidence majorly comes for anybody is because you have a lot of knowledge. The knowledge based on your academics will be limited, but you have to go outside your academics, and you have to keep exploring a lot in the web. And then put yourself, like, every single time when you go onto the web, you know that there will be 10 different things you have to construct. That, okay, I have read through all these things, and this is what pretty much dominating the conclusion it is, and from here what do I need to learn next? You have to construct your own pattern of learning stuff, right? Then by the time you end up your college, you will have a lot more confidence by yourself. And then you go to small companies for, or big companies for interviews. You could demonstrate much bigger what do you say, that confidence to the end interviewers also, such that you get an opportunities. So learn more about your electronics in depth. And second thing, improve your programming. Whatever in the academics is not sufficient, you have to learn more advanced programming, data structures and algorithm. These two things you keep on improving, so you'll have a plenty of opportunities outside.
That's a great
Thank you,
career
sir.
tips, Vishnu. And we are time up. I think it's time to wrap. So do we need to take any other questions, Vishnu? Like, do we have anyone have any questions, or else we can wrap up by giving a thanks note? Okay. And behalf of all students, Vishnu, I would like to thank on behalf of the JustPic team, and also I would like to thank for your time and your experience and your tips on different areas. And thank you so much for your time. And so I need everyone to be whoever possible to enable the video so we can take a screenshot of our all thing, and then we can wrap up. So Vishnu, you can stop sharing the screen. Yeah. Great. Thank you, guys. So I think we don't have any further questions, Vishnu. Thanks for your time, and I hope it has helped a few of our candidates who are part of this particular meetup. And guys, I would like to inform there will be a VLSI meetup with other person, where I will circulate an email. So and also be part of our meetup WhatsApp group, and please download the JustPic app too, and for more meetups on a different areas of skills. Thank you, everyone. See you in the next meetup then.
Thank you.
Thank you, Vishnu.
All the
Thank
best.
you, sir.
Thank you.
Thank you, sir.